Section 8.2 Angles and Triangles. Our goal today is to be able to classify angles and triangles. I'm doing this lesson from home, so there might be some pausing throughout the video so I don't waste time trying to write, which takes a lot longer from home. We will start by classifying triangles by their angles. We have an acute triangle. This is a triangle that has three acute angles. We should know that acute angles are angles that are less than 90 degrees. Our next triangle is a right triangle. This is a triangle that has only one right angle, and we all better know that right angles equal 90 degrees. So if we have a right triangle, what types of angles are the other two? Well, we know that a triangle has 180 degrees total. If the right angle takes up 90 degrees of that, if we take away 90 from that total of 180, we are left with 90 degrees. For two angles to have a total measure, a sum of 90 degrees, they have to be acute. So therefore, the answer to this question is acute. And hopefully this is not going to take too long for me to write, so I'll need to pause it here. But we have things later in the presentation that take a little longer. You'll see why I will be wanting to pause the video. Finally, we have an obtuse triangle. This is a triangle that has one obtuse angle. We know an obtuse angle is one that's larger than 90 degrees, so we could only have one obtuse angle in a triangle. Otherwise, we would go way above 180 in our measures. So we have right, obtuse, and acute triangles. We can also classify triangles by their sides. First, we have an equilateral triangle. This is a triangle that has three sides that are equal in length. Those little tick marks we see right here, the fact that they're all the same amount of tick marks, tells us the angles are equal, or the sides are equal, excuse me. They're all the same length. An isosceles triangle only has two sides of equal length, or at least two sides of equal length. So there could be three of equal length. So I guess an equilateral triangle also qualifies as isosceles. But all we need to have for isosceles is at least two to be equal. So this one could also be the same, or we could have a different measure for that side. Finally, we have a scalene triangle. This is a triangle that has no sides of equal length. So we'll usually see something like this. Okay, we have one tick mark, two tick marks there, and then we'll have three there. That will tell us all the sides are different. So what we're going to do on this slide is name the following triangles. This is for your benefit so you guys understand the notation when you're asked to use certain triangles. And then we'll name the equal angles and sides in each triangle. So again, there'll be a lot of pausing on this slide. We'll start with the triangle on the left, and we're going to name it by its vertices, excuse me. Though the order is not important here, we're going to call it triangle, I'm going to stay alphabetical, triangle DEF. You could have said FED, EFD, EDF, DFE, doesn't matter, as long as you name all three vertices. So the one on the right, and again I'm going to stay alphabetical, we're going to refer to it as triangle ABC. So that's my horrible triangle symbol there. There's the A, B, and C. So we're going to name the equal angles and sides for each triangle. Let's start with DEF because it's on the left. And we notice two tick marks here and two tick marks here. So we're going to say that sides FD and ED are equal. So as you see, the order of how we name the vertices doesn't matter as long as we've got them identified. So FD and ED. Notice we have that line segment symbol right on top of each of those. And since they're equal in length, we'll use the equal sign. So that covers our sides are equal. As for angles, well, we see those little arcs that are marked on the triangle. Right there, there. So we've got equal angles here and here. So we can identify these multiple ways. I'm going to go ahead and do it the simple way. And we'll just say angle F using one letter is equal to angle E. That's how I prefer to do it, but you may see a different way. I'm going to pause the video so I can write it up, and you'll see what I mean in a second. We could also use all three letters to identify an angle measure, as long as the vertex of the angle is the middle. So angle F, which is right here, could also be called angle EFD. Or I guess we can call it DFE, as long as the vertex, which is F, is right in the middle. So these are the same. Therefore, angle E, we could call F, there we go, FED or DEF. Again, as long as E is right in the middle. So if you want to pause the video now, you can, and identify the equal sides and angles in triangle ABC. I'm going to pause my end here and write up what is equal. So notice in triangle ABC how all of our sides are equal. So we must identify all of those. So I say line or side AC equals side AB, which equals side BC. Of course, you can change the order around. You could say CA, BA, CB, put in different split in places, as long as we have all three sides are equal. Same goes for the angles. Angle A right here equals angle B, which equals angle C. You could have used the three-letter notation, say ABC, BAC, BCA in some order. As long as you've got those vertices as your center letter, you're fine. Wasn't asked, but triangle ABC, we could say is equilateral. All three sides are equal. We could say it's also acute, since the only way to have all three angles equal would be 60, 60, 60. Then over in triangle DEF, we have an isosceles triangle, because for sure side FD and ED are equal. And as for our measures, well, we don't know yet, because while these two are acute, it looks like an acute triangle, but we can never assume triangles are drawn to scale. Now, we're going to call back on the knowledge that all triangles equal 180 degrees, and we're going to solve equations for missing angles. So we set up an equation by setting up all of our angles equal to or the sum of our angles equal to 180. From here, it's just equation solving. So we combine like terms on the left side. 42 plus 42 equals 84. So we have 84 plus x equals 180. And then we know for our one step after that, we subtract 84 from both sides, and we'll get our missing amount. So we end up with x equals 96. And we'll get that written here. So go ahead and you can try the next one on your own. Pause the video as I will and get the solution. Hopefully you found x equal 52 degrees. Here are the steps. We added 88 and 40 to get 128. 128 plus x should equal 180. Subtract 128 from both sides. 52 degrees is the value of x. How about a little challenge? Go ahead and try this one. The key here, solve for x. Notice the question says find the measure of each angle. So once you have x, you're not quite done. Give it a shot, pause the video. This should be your initial equation. Adding up all three angles, set them equal to 180. Next, we combine like terms. 3x plus x equals 4x. 10 plus 70 equals 80. We haven't touched the right side yet, so 4x plus 80 equals 180. It is now a two-step equation. We'll subtract 80 from both sides. From here, we divide both sides by 4, which should leave us with x equal to 25. Now remember, we found what x equals, but the question asks for the measure of each angle. So we're going to take this 25 and move it up and plug it in wherever we see the x. So we see x right here, so that makes it easy. So we have 25 degrees for that angle, and we know that one's 70. So we know 25 plus 70 equals 95. So this here better equal 85, because that'll give us a total of 180. So 3 times 25 equals 75, and 75 plus 10 does indeed give us 85 degrees for that angle measure. Everything checks out. This concludes your video for tonight. Bring any questions to class tomorrow, and have a good night.